The 19468 DC shunt is actually a low-resistance precision resistor used to measure AC or DC electrical currents. It does so by placing a resistance in a circuit and measuring the voltage drop across the resistance. You don't have to know about voltage drops or any of the math that will surely follow, just how to hook it up and take a reading. If you're interested in how it works, stick around. We'll get to that shortly, but first let's look at how to use it. Make sure the electrical system is turned off. Remove the negative battery cable from the battery. Install the shunt on the negative battery post and attach the battery cable to the post on the shunt. Set your meter to the millivolt scale and plug the red lead into the red terminal on the shunt and the black lead into the black terminal. Start and run the engine. What you read on the meter's dial is the rate of charge in amps being returned to the battery by the alternator. Turn the engine off and the key to the on position. Apply a load, such as turning on an electric clutch. What you read on the meter's dial now is the rate of discharge the battery is experiencing in amps. As mentioned, the DC shunt is essentially a precision resistor, or more specifically, the metal between the meter lead connection terminals is. All conductors provide some resistance to the flow of electrons, except for some in extreme circumstances such as extreme cold. 12-gauge stranded wire, for example, has 0.01588 ohms per 10 foot. Let's take a quick look at units of measure. The prefix milli is Latin for a thousandth of a unit. For example, 0.001 inches could be called a milli-inch. Therefore, 1/1000th of an amp equals 0.001 amps or 1 milliamp. If that's true, then 1/1000th of a volt equals 0.001 volts or 1 millivolt. Factoring these units of measurement for the Briggs & Stratton shunt into Ohm's law gives us 1 amp equals 1 millivolt divided by 1 milliohm, or 0.001 volts divided by 0.001 ohms. This equation shows that across the posts of the Briggs & Stratton shunt, 1 milliohm equals 1 amp of current flowing through the circuit. This is why we set the test meter to the millivolt range. Now let's take a look at charging current from the alternator flowing through the shunt. Resistance through the shunt will stay the same. We know the current will change. Since the shunt measures voltage drop across a resistance, we have to be interested in the voltage or pressure in the system. The resistance value of the shunt is set so there is a 1-to-1 ratio between amps and millivolts. Therefore, a reading of 2 millivolts on the meter face is equal to 2 amps of current. 3 equals 3, etc. An often unappreciated advantage of using the DC shunt is that we are measuring minuscule voltages which have little chance of harming the technician. Measuring high amperage directly is dangerous, and we can use any meter with a millivolt scale.